Okay, so let's take a look at our lesson for today. We are going to be talking about the ambiguous case. I need to talk to you about the other ones we've done so far because I need to do a comparison, compare and contrast, because it's really important that we recognize that this is really a special, unusual case. The ambiguous case is very, very unusual. In the previous lesson, we talked about side, side, side. We talked about side, angle, side. We talked about angle, side, angle. There's probably another one we talked about that I can't think of. So we talked about all those. Maybe it was angle, angle, side or something. At any rate, we talked about all those. This one, and those are just done normally like we've talked about. In fact, we have the names of them up here. So it was, it was angle, angle, side. So we talked about side, angle, side, 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 angle, 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 side. Those are normal, okay? Those are only going to create one triangle or no triangles. That's it. Nothing else. Now, when we get to ambiguous case, it's strange because, and so this would be like if you have a side and an angle. That's what ambiguous case is. And it's the only time you would use ambiguous case. Unfortunately, once I teach this lesson, some students are prone to think that anything could be have two triangles, and that is absolutely not the truth. The only type that could generate two triangles is a side-side angle. None of the others could. All the others are either going to give you one triangle or no triangles. All right, so what this diagram goes through, it kind of shows you the scenarios. And I don't memorize this A and H business. I don't. I'm going to show you a different way to do it, which actually makes it much easier. But I just want to kind of talk through the way that it looks. So we can see that, like in this first example, this side and this angle would not produce a triangle. You see the little side A is way too small to be able to come up with another to come up with a triangle. So this would be like a no solution. The next, we have several different cases where, and this is also a no solution, if you want to compare the A's and the B's business. And that what they're talking about is these A's and B's. But again, I don't really focus on that. I'm just focusing on the pictures, on the diagrams. So it's also possible to get one solution. It might look like a right triangle, it might look like this, or it might look like that. It is possible to get one solution for this particular scenario where you have two sides and the not included angle. And the third case is it's actually possible to get two triangles. It is actually possible to do that. And this would be a picture of how that could happen. Like the side could go this way or this way, and it would create two different triangles. Okay, so that's our overview. That's kind of just a big picture on how in the world could we get 0 triangles or 1 triangle or 2 triangles. So what I would like to show you, the technique and this technique will just work for side-side angle. Please don't use this technique for anything else. So what we're going to do is we're going to use law of cosines for those. Those are all side-side angles. And I want to draw a picture of what we're looking at. So we're going to use our calculator. We're going to use the graph for part of our calculator. And so here's, like, say, the XY. I don't know if I could get it straighter. There's like the regular coordinate plane. Let's say that, so we're going to have, we know that it's, let's just write like a squared equals b squared plus c squared minus 2 times b times c cosine a. Okay, so that's like a version of the law of cosines. So what we're going to do is we're going to take this number right here, and we're going to enter that in F1 in our calculator. F1 is going to be the a squared number, whatever that is. Okay. F2 is going to be the rest of this formula, the rest of it. And that's how we're going to enter it. So this is the rest of the formula. So here's what we're going to be looking for. So let's say that this is our, let's say this is our a squared, whatever that number is. Maybe it's a 5. I don't know what it is, but that's a squared. Okay. The way that we're going to be able to tell how many triangles we have is by the shape of the parabola. So this right here, that's F2. This is a parabola because B is going to be like x squared. This is going to be a parabola. And so what we might have is we might have something that looks like this, where the parabola does not touch a squared. This would be no triangle. This would be a scenario with no triangle. We may have a scenario that looks like this, where it crosses 2 times and the positive x side. This is going to generate 2 triangles. Or we may have a scenario that looks like this, and in this scenario, it crosses the positive x 1 time, and let me make it a better picture. So this is a positive x, and this is a negative x. We know that sides of a triangle can't be negative, so this would just generate 1 triangle. So the power of doing it this way is we will immediately know whether there are no triangles, 2 triangles, or 1 triangle, and then we can navigate from there. So that's how we're going to set up each one of these. Okay, so I'm going to write this out in words. So here's what we're doing. We're going to find 2 things with this scenario. 2 things. Number 1, we're going to determine the number of triangles. That's what, when we do this in our calculator, we're going to figure out how many triangles. And number 2, we're going to determine the values of the missing side. Since this works only for side-side angle, we have 2 sides and we don't have 1 side. So this, what we're getting ready to do, is going to do 2 things for us. It's going to first tell us how many triangles we're going to have to work on. And secondly, it's going to give us the value of the missing side. All we're going to have left to do is to find the missing angles. Okay? So I want to pause there for a second to see if I have any questions on what I just talked about. Is everybody okay? Okay, so let's take a look at our first example, keeping those things in mind. That's our scratch work. That's what we're working on. So we're going to go here to this first one, and let's draw our triangle. These are all triangle XYZs, and it says solve the triangle. What does that mean by solve the triangle? It means find all missing sides and angles. I mean, that's what solve the triangle means. They want you to find all the missing sides and angles. All right, so let's draw this. So this is triangle XYZ. Side X is 4, side Y is 5, measure of angle Y is 27 degrees. So therefore, this is a side-side angle. It's a side-side angle. All right, so what do? We're going to set up our law of cosines. So, and we're going to have to use this as our anchor. The only angle that we have across from that side, that's got to be our anchor every time, because it's the only angle that we have. So we would say 5 squared equals, and this is side Z. So in my formula, I'm going to use Z squared. In my calculator, I'm going to make it an X, because our calculator really doesn't like us using other letters. The calculator wants us to use the X. So z squared plus 4 squared minus 2 times z times 4, cosine of 27 degrees. Okay. Is everybody good? So what I'm going to do is I'm going to take that information, I'm going to pull up my calculator, and I'm going to insert all that information into my calculator, and we're going to figure out how many triangles that we have. So let's pull my calculator up. I want to go add a graphs document. All right, and I had my F1 is what it's equal to, which is 5 squared. I'm not going to take a chance on, remembering what 5 times 5 is. I'm just going to put 5 squared and hit enter. To get the second one in, you hit tab, and I'll show you in a moment how to see everything. We can't see everything yet, and I don't want that to bother you. That's okay that we can't see everything yet. Okay, we will see stuff in a minute. I'm going to hit the tab, and my F2 is the right side of the law of cosines. So I'm going to use an x, so x squared, then it was plus 4 squared minus 2 times x times 4 times cosine of 27 degrees. I'm going to pause here for a minute, and we need to be sure that our calculator is in degrees. So make sure you've got degrees. And before I hit enter, I want to just make sure everybody's following with me. Because I don't trust the calculator, I'm putting times in between all those things that need to be multiplied together. 2 times x times 4 times cosine 27. Okay, does everybody have that calculator input done? Yes, so now I'm going to hit enter. Now, I can't see, I see this, that's great. If we go back up here, tab, and we go up here, this is like 25. Okay, I can't even, if you look at this goes to 6. I can't see a 25. So what I do, and you might not want to do this, this is my thing that I do, I go to the window and I go to the settings. Maybe you don't like that and you want to zoom out, number 4, go for it. I don't care, I do zoom settings. So I want my Y max to be like, I don't know, 30 or 40. Okay, so now I can see everything. So this parabola does cross this line twice. Here, that's legitimate, that's a positive x. But what does this mean? Crossing over where the x's are negative. Is that a valid side measure of the triangle? It's not, is it? I can't have an x value that's negative. So this is going to create one triangle. It's going to create one triangle. And so, and this value, this intersection is going to be the side of the triangle. So let's go ahead and calculate that intersection with our calculator. We do menu, analyze graph. See, number 4 is intersection. So we go over here and we click that up. That's the lower bound and that's the upper bound. And there. Now, let me tell you something very important. Some of the ladies in the previous class figured this out. If your calculator is not giving you more than 1 decimal place, you're going to get problems wrong on the homework. What your calculator is doing is it probably says float or something. So I'm going to go through that right now with you. So to be sure to fix this, because I don't want you to have the same problems the other ladies did. To fix this, you go to the menu. While you're in the grapher, you need to be in the grapher. You go to the menu, you go to settings. You want this display digit to say fixed 4. And you can, it's all the way down underneath all the floating things. Make it fixed 4. Okay, so fixed 4 and OK. Because if you don't have it like this, you're going to get problems wrong. I'm just telling you. Because the textbook questions, the homework questions, want us to go to the hundredths place. They want 2 decimal places. And so you have to have a minimum of 2 decimal places. Also, when you're doing the rest of your calculations, you just need to use this big number, the whole number that you see. Don't round it. All right, so I hope that makes sense what I'm saying. So let's go back to any questions on the calculator? All right, let's go back to our work. And so I know that Z is, what was it, 8.223. And I know that there's one triangle. Okay, I know there's one triangle, just one. Great, so now I have all the sides. So I could even write this up here. That's like 8.223. Now, the angle that we find, I can't emphasize this enough. The angle that we find cannot be the largest angle. You cannot find the largest angle with law of sines. Please don't do that. Pick the smaller one. So we have two choices. We need angle X and angle Z. Which one should we choose to find? There's only one correct answer. Angle X, because it's the smaller one. We should not try to find angle Z with law of sines, because if it's obtuse, it will give us the wrong answer. So let's do our sine. So sine of 27 degrees over 5 equals sine of X over 4. Okay, so I'm going to multiply that out. So that gives me 4 sine of 27 degrees equals 5 sine X. So I'm going to divide by 5. So I know sine of X is going to be 4 sine 27 degrees over 5. Okay. 4 sine 27 degrees over 5. Is everybody okay with that? All right. So now I'm going to go to my calculator and I'm going to input that in my calculator. So we're going to do a calculating page. So I'm going to do Control Doc. That gives me another page. I want a calculator on there. I'm going to do a fraction, which is Control Divide. And I'm going to put 4 times sine of 27 degrees over 5. And now I'm going to do Control Enter. And that is not the angle. I hope we're clear with that. That's what sine X equals. Sine X equals this number. So I need to do inverse sine. So inverse sine, and please use this arrow to go up and grab that number. Use the arrow, go up and highlight it, and hit enter, and it puts the whole thing right here, the whole gigantic number right here, which is what you want. And now we hit Control Enter, and that gives us our angle measure. So it's 21.296. So let's go back over here, and we know that angle X is 21.296 degrees. Now, I'm not going to do law of sines again. We know stuff about angles of triangles, right? What do all the angles of a triangle have to add up to be? 180, right? That's what they have to add up to be. So we're just going to add, I'm going to add the 21.296 plus the 27, and then I'm going to subtract it from 180. So I'm going to pull this number down. I'm going to add 27 to it. And then I'm going to say 180 minus this number. And that gives me, oh, and that's obtuse. So we would have gotten into big trouble if we had tried to find angle Z with law of sines, because we would have gotten the wrong answer. Okay, so that's 131.704. Okay, so angle Z is 131.704 degrees. And so this piece right here is my answer. That's my solution. All right, how are we doing so far? Everybody okay? Okay, let's set up our next one. So we'll draw our triangle. So we've got X, Y, and Z. Side x is 6, side y is 5, and measure of angle y is 27 degrees. Okay. All right, let's, so this right here is our anchor. That's what we're using as our anchor for our cosine, law of cosines. So I have 5 squared equals, and again, I want to find z. Z squared plus 6 squared minus 2 times z times 6 cosine of 27 degrees. Okay. Now, I prefer reusing the grapher that I already have, so I'm going to go up and adjust the numbers. If that troubles you, you can just start a new page. But I'm going to use what I already have. So is everybody okay so far? Yes? All right, so let me get back to the grapher. So I'm going to go back to my graphing page. I'm going to hit my tab and go up all the way to the top. And, oh, that's still 5 squared, so that's okay. I'm just gonna, now let's go fix this one. So this one needs to be moved. So when I move my little cursor over, let's see, that 4, I'm gonna delete, that 4 needs to be a 6. Then let's keep moving over. That 4 needs to be a 6. Okay. Let's check it. Now, x squared plus 6 squared minus 2 times 8. Okay, that looks good. Hit enter. Oh, look what we have now. How many triangles is that going to make? 2. That's going to make 2 triangles. I have 1 triangle here and 1 triangle there. 2 different triangles. Okay, well, let's work on triangle number 1. I'm going to make this triangle number 1. So menu, analyze graph, intersect. So we intersect here. And there's my triangle number 1, 1.153. So let's go back and let's kind of get that set up. 1.153. So I'm going to do a couple of things. I'm going to say this is triangle number 1. And I'm going to draw the triangle down here since there's 2 different ones. I don't want to get confused. It's very easy to get confused on this. So that was a 5, that was a 6, that's a 27 degrees. So in triangle number 1, our side Z was 1.153. 1.153, was it 4? 1.1534? No, 1.1532. Okay, that's what it was. 1.1532. Okay, great. Now I am going to have a triangle number 2. I would prefer to finish the first one I'm on if that's okay with you. Okay, so I need to figure out which angle I want to find. Okay, this time, should I find angle X? No. Why not? It's across from the biggest side. Avoid, avoid, avoid. If I can't say that enough, I don't know. So we're going to do sine of 27 degrees over 5 equals sine of Z over 1.1532. Okay? So let's go to our calculator. Make this a little bit smaller. Okay, so we're going to put, what would that be? That would be, now, is everybody okay with the calculator input for this? Are we good with that? Can I just kind of put the answer down? Is that fine? We would just do it just like we did this one over here, just to help us go just a little quicker, if that's okay. All right, so when we do that, we're going to get that angle Z is 6.01 degrees. So angle Z is 6.01 degrees. Then I add 6.01 to 27 and subtract from 180, and I get that angle X is going to be 146.990 degrees. And oh, we would have also been in big trouble had we tried to find angle Z with law of sines. We wouldn't have gotten that. We would have gotten something else. Okay, are we good on the first triangle? All right, let's move to the second triangle. And I guess let me do it in a different color so that it's apparent that these are different triangles. So this one, this is going to be triangle number 2. And we still need to find the side first. So we're going to go back to our calculator and we're going to find that second intersection right here. So we do menu, analyze graph, intersection. So I go to the left and to the right, and there's my intersection right here. Let me move it out of the way. So 9.5389. 9.5389. Okay. So here we go. So Z is 9.5839. So let's draw that triangle so we don't make a mistake. This is triangle number 2. So that was 5 and that was 6, and this is 9.5839. And that is 27. Okay, which angle should we find now? Which one now? Angle X. Yep. So sine of 27 degrees over 5 equals sine of X over 6, because we always want to find the smaller one with law of sines. We put that in our calculator, and we get that angle X is going to be 33.010 degrees. So we calculate angle Z, which I would just add 27 plus 33.01, subtract from 180, just like we did on the other one, and that's 119.990 degrees. So let me give you a little point of warning. In the homework, the ones that generate 2 triangles, they're going to give you instructions on which triangle to put first and which triangle to put second. If you ignore those instructions and you reverse the triangles, it's going to count it wrong. It's going to tell you which one to put first. Please read those instructions, okay? It's going to tell you. So, just giving you the heads up. That happened in the last class also. Okay, be sure that you put the one they want first. All right, last one. Here we go. So let's see what we got. So X, Y, Z. Angle X is 27 degrees. Side X is 2. Side Y is 5. We have side angle again. Our anchor is going to be this one now. So we've got 2 squared equals, and we still need side Z. Z squared plus 5 squared minus 2 times Z times 5 cosine of 27 degrees. Okay? All right. Everybody okay? If you would then, let's go to our calculator and let's put this in. Let's see what happens. So again, I'm going to use this same scenario, and I'm going to hit tab, and I'm going to go back up to the top. Now this number is supposed to be 2 squared, so I'm going to change that to 2. 2 squared, enter. Okay, so now let's tab back up. Let's go change this. Let's see, what's that supposed to be? So that 6 is supposed to be a 5. Oops. So 5. Let's go over here. That 6 is supposed to be a 5. Okay, is that right? Yes, enter. Oh, what's going on here, ladies? Do we have a triangle? No, it doesn't cross. There's no X values. So this one is very clear. There's no triangle for that scenario. So our answer would actually be I mean, crazy enough as it seems, there's no triangle. Okay?